In this video we're going to look at placing fractions on a number line. So we're going to look at placing fractions on a number line up to 1 and a number line over 1 and placing fractions with different denominators on a number line. So first of all we're going to look at a number line here that runs from 0 to 1. And I'm going to put these dashes on it. So we've got 0 to 1 and we have 1, 2, 3, 4, 5 dashes after our 0. We have our whole and it's been split into 1, 2, 3, 4, 5 equal parts. That means we know each dash is going to be worth a fifth. So if I write on here 1/5, so we've got 0, 1/5, 2/5, 3/5, and finally 4/5. We know that 1 would be 5/5. 1 is equivalent to 5/5. So it's important to count the gaps, the space we have there. So we have 1, 2, 3, 4, 5. So we know that we've got fifths. Right. Let's just look at one other example, one more example. So we go from 0 to, let's do it a little bit lower. We'll go from 0 to 1 again. Now we've got equal gaps here, and let's see how many gaps we've got. I'm going to do this with my orange. 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 spaces between, or gaps between 0 and 1. That means I know each dash is going to be worth an eighth. So we've got 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 1. Some of you may now be thinking, oh, Mr. Miller, I've seen some equivalent fractions here. So you might realise that actually 2/8 is also equivalent to a quarter, and 4/8 would be equivalent to a half, and 6/8 be equivalent to 3/4. These numbers along the top are all simplified fractions. So that would be our number line for putting fractions on a number line up to 1. Now we still do the same, apply the same principle when we're going over 1. So imagine I had 0 to 1 there. We ended up with a number line like this. So it's gone past 1. We still count how many gaps we've got. We've got 1, 2, 3. That means we've got thirds. So we've got thirds. 1/3, 2/3, 3/3 would be 1. We also then know that this will continue on. Okay, so we're counting up in thirds. 1/3, 2/3, 3/3, which is a whole, and then we'd have 4/3, which is equivalent to 1 and a third, and then we'd have 1 and 2/3, and we'd just carry on and carry on and carry on. Okay, so that's going over 1, putting fractions on a number line going over 1. Now let's have a look at a number line where we have to put fractions on with different denominators. So 1, So here we've got a number line running from 0 to 1. We may be asked to put on that number line the following fractions: 7 twelfths, 5 sixths, and 3 quarters. Oh, let me just put those on so you can see them. They haven't just. So 7 twelfths, 5 sixths, and 3 quarters. Now, what we need to do here is first of all work out what each dash stands for, what fraction. So we're going to count up the gaps: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know that each dash stands for a twelfth. 1 twelfth, 2 twelfths, 3 twelfths, etc. I could mark on all the twelfths. Now, I only need to mark on these 3 fractions. I can easily mark on 7 twelfths because I just count up 7 times. 1 twelfth, 2 twelfths, 3 twelfths, 4 twelfths, 5 twelfths, 6 twelfths, 7 twelfths. So I know that 7 twelfths, I can put my answers actually above the line. I know that 7 twelfths is going to be here. Now, I can use my equivalent fraction knowledge to convert 5 sixths into twelfths and then find 5 sixths on my number line. So 5 sixths is equivalent to how many twelfths? Well, we multiply our denominator by 2, so we multiply our numerator by 2. 5 sixths is equivalent to 10 twelfths. So I know that where we have 10 twelfths on here, 7 twelfths, 8 twelfths, 9 twelfths, 10 twelfths. I could have counted back from 12 twelfths, 11 twelfths, 10 twelfths. I know that at 10 twelfths I'm going to have 5 sixths. So there's 5 sixths. I also, children, can convert my 3 quarters into twelfths to place 3 quarters on the number line. So let's look at doing that just here. 3 quarters equals how many twelfths? Well, we multiply 4 by 3 to get 12. We have to do the same to our numerator. So 3 times 3 makes 9. So 3 quarters equivalent to 9 twelfths. Have to find 9 twelfths on here. That's just 1 less than 10 twelfths. 9 twelfths there. So 3 quarters goes here on my number line. So it's important, children, to find those equivalent fractions. That's why equivalent fractions are so important, why we look at them so much. They also come in to solving problems involving fractions on a number line.